today we are going to prove the sum and the difference of angles using sine and cosine. So this is in Advanced Pre-Calculus, Chapter 5, Section 4. And let's go ahead and get to it. We're going to start with the unit circle, because that's where all good sine and cosine calculations start from. And we're going to put a few points on the unit circle. At 1, 0, we're going to put a point, and I'm going to call that point H. Then we're going to put another angle in the first quadrant. I'm going to call this angle B. So this point is cosine B, sine B. And then over here in the second quadrant, I'm going to put an angle A. So this point will be cosine A, sine A. And then somewhere in between the two of them, and this will not be to scale, I'm going to put another line, and I'm going to call this angle cosine, or I'm just going to call that angle A minus B. So if that's A minus B, this point is cosine A minus B, sine A minus B. Okay, so we have point H. I'm going to call this one I. I'm going to call this point J, and this point K. Okay, that's a pretty small drawing, and I've crammed a lot of things in there, but what we need to do is realize that for all of these angles, I can draw some chords, so I can connect from A and B, from I and J, I can draw that line. So line segment IJ is a chord, and then I can also draw a line segment HK. And had I drawn those to scale, you would see angle A minus B is the same for both of those line segments. So line segment IJ, line segment HK. And what we're going to do now, since those chords have to be the same length because the radius is the same and the central angle is the same, we can use the distance formula, and we can look at the distance is the square root of the difference in the x's squared, difference in the y squared. So I'm actually going to do HK on this side. So HK would be cosine A minus B squared minus 1. Oh, I'm sorry. Cosine A minus B minus 1 squared plus sine A minus B minus 0 squared. And that will equal the IJ line segment, which would be cosine A minus cosine B squared plus sine A minus sine B squared. Okay, now I'm going to step through some algebra. The first thing I'm going to do is square each side, and after squaring each side, I'm not going to rewrite that. Now I'm going to FOIL everything. So cosine A minus B minus 1 will be cosine A minus B squared minus 2 cosine A minus B plus 1. That takes care of that first binomial. Now, sine A minus B minus 0 squared is just going to be plus sine A minus B squared. Now it's going to equal, and I have to go down to the next line for this because this is pretty long. It's going to be cosine A squared minus 2 cosine A cosine B plus cosine B squared. That's the first binomial here, plus sine A squared minus 2 sine A sine B plus sine B squared. Okay, now, do you remember the trig identity? Cosine squared plus sine squared equals 1. Okay, and then we have another one here, so it's 2 minus 2 cosine A minus B. That's what this side simplifies down to. Now the second side, you have cosine A squared, sine A squared, cosine B squared, sine B squared. So that will be 2 minus 2 cosine A cosine B minus 2 sine A sine B. Believe it or not, we're almost done. So if we subtract 2 from each side, the 2's go away. And then if we divide negative 2 on each side, we get cosine A minus B is equal to cosine A cosine B plus sine A sine B. Okay, now that is our first of 4 identities. So we have cosine A minus cosine B. Well, I'm going to try something cool here. I'm going to say cosine of A minus negative B. I can do that, right? I just replace B with negative B. And that will be cosine A cosine negative B plus sine A sine negative B. Well, I did that because cosine A minus negative B is cosine A plus B. And then over here, cosine A stays the same. Cosine negative B, because that is an even function, that's equal to cosine B. If you don't remember that, go back and look at your odd and even identities. And then sine negative B in the second part here is negative sine B. So this becomes negative sine A sine B. There's our second identity. So the second identity, way easier after we get the first. Now, the third identity, we're going to use cosine of pi over 2 minus theta is equal to sine theta. So that's the concept we're going to use. That's the phase shift identity. And we talked about that in class a couple of times. So I'm going to say sine A plus B is equal to cosine pi over 2 minus A plus B. Okay, so this is really cosine pi over 2 minus A minus B. So we have cosine of an angle minus an angle. So we can go up here. This will equal cosine pi over 2 minus A times cosine B. And because this is cosine minus cosine, it's going to be plus sine pi over 2 minus A cosine B. Okay, cosine pi over 2 minus A is sine A cosine B plus cosine A. I'm sorry, cosine A I've lost my mind a minute here. This should be sine here. So this is cosine A sine B. So this is our third identity, just to clarify. Sine A cosine B plus cosine A sine B. So that is our third identity. And on the bottom of this page, we're going to fit the fourth identity. And we're going to do the same thing here. We're going to say sine of A minus negative or plus negative B. That will end up being sine A minus B. So sine A plus negative B will be sine A cosine negative B plus cosine A sine negative B, which simplifies to sine A cosine B minus cosine A sine B. This sign right here changes because sine negative B is an odd function. The sign here does not change because cosine is an even function. I hope that clears things up for you. Have a wonderful day.